Hello, I'm Hiroki Yamada, CEO and CTO of Scalar. Today I'm going to talk about our product called Scalar DLT, which is a blockchain-inspired distributed platform. I think it's more precise to call it scalable and tamper-evident distributed database in a private network. The reason why we don't call it blockchain is that we don't use blocks, and we don't use chain structure anymore. It basically uses a DAG-based linked records. So today I'm going to talk about a little bit like philosophical aspects of our technology to kind of describe our business a little bit. So, by the way, why are we developing this kind of technology or product from scratch, even though there are lots of existing private blockchain players or products? Some private reason is that, like, it's my personal reason is that, like, I really feel like the existing private blockchain products are missing the point. And then, this is a kind of public reason. My major reason is that in systems, one size basically doesn't fit all. So it's kind of word from Michael Stonebreaker. He is a ACM Turing Award winner, also a professor at MIT, and then he's a database researcher. So the relational database used to be a one-size-fits-all solution, so that the one relational database can be utilized for multiple purposes. But he said it's no longer applicable now. And then the similar things also has said by Werner Vogels. He's a CTO at Amazon. And then he said like one-size-fits-all database doesn't fit anyone. So this is the main reason why Amazon AWS has so many database products in their cloud. And I think I really agree with this. And then this applies to the blockchain domain also. So there is no one blockchain which solves lots of use cases or lots of problems. So let's look at the Bitcoin blockchain. So Bitcoin blockchain is basically designed for electronic cash over public peer-to-peer network. So since it's deployed to public peer-to-peer network, it basically assumes frequent forks. So what it means here is like it basically forks even if there is no malicious activities. And then so basically, even if everyone works properly, it basically forks very frequently. So for more detail, please look at my paper written in 4 years ago with Kenji Saito. Basically proves why blockchain is a probabilistic state machine. And then ICDC is one of the major conferences in distributed systems. So also, it's basically designed for tolerating Byzantine faults. So that's because it needs to kind of deal with the frequent forks, and also the number of nodes, n, is kind of pretty big in peer-to-peer network. I think it really makes sense to me, but is this kind of architecture or these assumptions really effective in a private network? I don't really think so. However, most of private blockchains still assume the same assumptions, basically. So it assumes frequent forks, even though it doesn't fork unless malicious attacks happen. And then it's also designed for tolerating Byzantine faults, even though n, in this case, n is the kind of the number of independent organizations. But even though n tends to be small in enterprise systems. So it doesn't really make sense to me. So our Scalar DLT is basically more toward the practical assumptions. It's designed based on more practical assumptions. So it assumes infrequent forks. So that's because it doesn't fork if there is no malicious activity. So I think makes sense to me. And it prefers tamper-evidence over Byzantine fault tolerance because n tends to be small. So tamper-evidence in this case, as long as n is bigger than the number of faulty nodes f, so it's kind of assures the tamper-evidence. So by this kind of relaxation, we can basically decouple tamper validation from execution, which is our patent pending technology, and which makes it possible to achieve good scalability without losing tamper-evidence. So So this is why we can achieve scalability and tamper-evidence both. So it works especially under many end users and devices interacting with one or more few organizations through our scalability transactions, aka smart contracts, for tamper-evident traceability and controllability. So some use cases would be like information banking, 情報銀行, and then GDPR, CCPA, and digital documents rights. And in the future, edge-heavy applications would be our kind of target. So I'm going to show you a quick demo about our solution template with Scalar DLT for information banking. So let's assume there's a data owner who wants to store his personal data to information bank. So he kind of store his personal data signed by his private key, stored in Scalar DLT through the information banking, so that it can be later validated by the public key. So to assure that's the origin of the data. And then you can show your personal data at the teller window to show who you are, very simply. And then you can pass your data to the third party, some third party as requested. So once you agreed with the condition, you can pass your data through the information banking to the third company. So thank you very much. And then I'm very looking forward to talking with you, like investors, potential customers, potential partners. We want to talk. I want to talk with you. Thank you.
Thank you, Hiroyuki.